Okay, now let's keep working on the second section of the challenge problem for this chapter. Okay, so the problem 56, it mentioned the base of the two flagpoles. Okay, I have two flagpoles 12 feet apart. Okay, and one flagpole is 14 feet and the other is 11 feet. So a wire is run directly from the top of the first to the top of the second the small flagpoles, then to the ground without bending or curving at the point. Means it's the line extension. Just draw on the ground. So how far from the base of the small flagpole does it reach to the ground? Okay, it's asking us to solve the x, right? So here, I mean, if you really learn the similar triangle, okay, basically the triangle of this one, okay, is similar to triangle of this one. Okay, so with knowing the similar triangle, basically let's draw an extension here. So here is the 11, here is the 3, right? Okay, so x over 12 is equal to the 11 over 3. Now let's solve. X is 44. Okay. Next, a line has slope of -2 passing through the point of this. Okay, so now let's write the line. Line 1, slope of 2 passing through this. So it's y minus -3 equal to the -2x minus r. A second line k is perpendicular to L at this. Okay. Here you need to know one thing, okay? I give you a example, okay? So any line, okay, let me draw any line, I'm sorry. Shouldn't passing through the 0, right? It's x, y, 0, okay? So if this line is k x plus b, its slope is k, right? So basically we can find a line parallel but passing 0, 0, okay? So this one is the angle of the alpha, it's the angle of the alpha, right? So this is the tangent alpha is the slope. So we can find a line passing through 0, 0. It's y equal kx, right? So if we want to draw another line that is a perpendicular, so this is the 90 degrees, right? So here is the 90 minus alpha, and so this is the alpha, right? Okay, so you can see the other angle, the angle of this one, right? The angle of this one, this angle is 90 plus alpha. Okay, so we can know that tangent 90 plus alpha equal to the -1 over k. Okay, so here the perpendicular, okay, if line 1 is perpendicular to line 2, so we have the k1 and the k2. It's very important is k1 times k2 equivalently is -1. So that's why for the L2, I know its slope is half, right? then I can do the y minus r equal to the half of the x minus 6. Okay, so now because we want to solve the crossing point, right? The crossing point is both satisfy equation 1 and equation 2. So now we can try to solve it. So let's solve it is the y, use the replacement. From the 2 is y equals the half of the x minus 3 plus r. Then we can replace this one to 1. So this one is half of the x minus 3 plus r, then plus 3 equal to the negative 2x minus r. Then we can cancel. Then finally we get the it's same thing as the 5 over 2 of the x equals r. So we get the x equals to the 2r divided by 5. Because this is the crossing point, so that's why a equal 2r over 5. Okay. Next. Okay, next. How many points are common to graph on the two equations? So if you see this one equation, okay, basically it mentions it's two lines because it's this one is the x minus y plus 2 is equal to 0, or the 3x plus y minus 4 is equal to 0. This is another two lines, x plus y minus 2 equals 0, or the 2x minus 5y plus 7 equals 0. Okay, so you can do 1, 2, 3, 4. Okay, so basically we try to construct the 1 and the 3 has a crossing point. 1 and 4, then 2 and 3, and 2 and 4. Okay, after solve these solutions, you will see all the crossing point A, B, C, D, they are different. So the answer is 4. Okay, but here I want to let's sketch the graph of this one. Okay, sketch the graph is really important. X, Y, O. So the first is y equal x plus 2, right? So it parsing the 2. Y equal x plus 2. It's 945 degree. This is the 1. Okay. Now let's draw the 3. X plus y equals 2. Let me use another color. Okay, so that's 1 point. Now let's draw the second one. Is 3 y equal negative 3x plus 4. Okay, so this is the 2, this is the 3. Now let's draw the 2. Is 4. 4 is here. Negative 3. Okay, so when the y equals 0, x equal to 3/4, so that's here. Okay, so the other one is, so we have another point here. Yeah, okay, on the red, I'm sorry, should be cross on the red. Okay, the last red line is 2x, so it's basically, it is the 2 over 5x plus 7 over 5 equals y. Okay, so let's draw it. 5 over 7 is a little bit above 1, and 5 to the y equals 0, x equal to the negative here. Okay, so now you can see this one crossing the 2 red is here and here. This one crossing the 2 red is here and here. So basically we have the 4 point. Okay, let me notating is 3 and 4, so this is the A, B, and 3 is C and D. Okay, these are all the points. Next, okay, so given a real number r between 0 and 1, there are 2 points. Okay, let's draw the picture. So we have the p of the x1, y1, and we have the q of the x2, y2. Okay, so we want to find some point that pt over pq equals r, where it is the between r is between 0 and 1. So we want to find pt and pq, right? Okay, so pt and pq is really between, it's the direction. If you consider about the direction, right? pt and pq, and pt is really between, and the should be somewhere here. Okay, so t should be between p and q. Okay, that's A. And B is, what happens if you allow r to be greater than 1 in your formula? Okay, I mean, if we consider also the negative ones, we need to do this. Okay, so t is between the q prime. Okay, so t is between the q prime and the q. Okay, if we only consider the length, you don't consider the direction. I'm not so sure about whether this is the directional or not direction. Okay, let's consider the non-direction first. So the second one is the it's allow the p is pq, pt over pq, pt over pq is greater than 1. Okay, if we consider the directional, the t should be on the extension of from the q. Okay, t belong to extension from the q. The c is to be negative. Okay, now I understand. So this one talks about the directional. Okay, if it talks about the directional, let me correct it. T need to belong to PQ. Okay. Okay, then if R is negative, R negative means the directional is means this. Okay, so if we define this direction is positive, so the PQ is positive. Okay, then if we go the other directions, okay, the PT should be negative. That's why you can get PT over PQ is R should be less than 0. Means they are on the different direction. So if you have the K, this one, so T belong to the extension from the P. Okay, so it's here. Let me use the different colors. Okay, so here is R less than 0. Here is PT over PQ greater than 1. Okay. And here is the PT over PQ less than 1 and greater than 0. Okay. Last question. So this question, when I see this, is always very familiar with the geometry. Okay. So this one is like D1, D2, D3. Okay. Normally it is there is a point P is fixed and the point Q is fixed. Okay. And we try to find some either middle point to connect them, right? 1, 2, or we try to find 2 points. This is the first segment, D1, D2, D3. And we want the D1, D2, D3 to be the smallest, right? Here is a mirror symmetry. So normally we do is the 1 segment, 2 segment, 3 segment constructing from P to Q, and we always do the symmetry to the P, and here is the Q, and now we find this one. Okay, 1 point here and 1 point here. So now you can see the AB. So the PA equals P prime A, right, by the symmetry. Okay, then the AB, then the ABQ is the line, right? So ABQ is the shortest. Because if I pick any other B prime, right, and this one, you can see the triangle is the 2 sides add together greater than the third side. So if you pick any AB prime plus B prime Q, it will greater than the ABQ, right? Okay, so the PA equals to the P prime A, and you can see if I draw a line, right, P prime ABQ is a line equal P prime Q, so this is the shortest. Okay, so it's always something you need to think something like this. Now let's see. Okay, so how to construct the a squared plus 9? Okay, the a squared plus 9 is like I have a 1 point, I have the other point. Okay, and that's this. The second one, okay, b minus a squared plus 4, right? So the second is I have this point and I have this point. The last one, okay, is 8 minus b squared plus 16. Okay, it's something like we have the b and the 2, then we have the 8 and the 16 is 6. Okay, so now you can see I equivalently construct a problem is xy. So here is the fixed point P, here is the fixed point Q. Okay, then we need to find A0. So here is A is on the x-axis and B2, right? So B is on this line, B is on the y equals 2, and A is here, B is here, and we want to see this is the A, right? And this is the 8 and 6. This is the Q. This is the P. I'm sorry. So this is the P, right? So this point is called A, and this point is called B. Okay, now let's see. Based on the same thing, right? So we need to do the 0, 3. Let's flip it over x-axis. Because why we flip x-axis? Because A is on the 0, right? A is on the x-axis. So we want to create this one equal this one, right? To get this one equal this one. So that's why the P prime is 0, negative 3. Then we can connect it this one, right? So now we find that this is the A and this is the B, right? So if you can find any B prime, you can connect any B prime here. The two sides more than the third sides, right? So now let's see the PQ MIN, right? P prime Q is the mean distance, right? Is equal to the 8 square plus the 9 square is equal to the 64 plus 81 is equal to the 145. Okay. And also, let's try to solve where is A and B. Okay, where is A and B can do this. So now we can, based on the P prime Q, we can solve this line, right? So the K of this line is 9 over 8. So this line is y plus 3 equals the 9 over 8x. Okay, so because A is on the x-axis, means y equals 0, right? Means we set y equals 0. Then we get the y equals 0. Then x equals 8 over 3. That's A. Okay. Now let's solve the B, right? The B we need to set y equals 2, right? So now you can set the B is y equals 2. Then here is 5 is 40 over 9. Okay. Now we also find the A and B to satisfy this. So that's all about the problem for these chapters. Okay, thank you.